According to the National Electrical Code, specifically Section 555.17b, a push button connected to shunt trip coils cannot serve as the disconnecting means for show receptacles. This code section dictates that the disconnecting means must be readily accessible and situated no more than 30 inches, which is 762 millimeters, from the receptacle it controls. A push button connected to shunt trip coils falls short of meeting these stipulations for a couple of reasons. Firstly, it is not considered readily accessible. Secondly, it is not located within 30 inches of the receptacle. The concept of readily accessible, as defined by the NEC, implies that the disconnecting means should be operable without the need for special tools or extensive knowledge. In emergency scenarios, swift and effortless operation of the disconnecting means is paramount. A push button, particularly one connected to a shunt trip, may not meet this criterion. Push buttons tied to shunt trip coils are generally mounted on panels or enclosures positioned some distance away from the receptacle itself. This arrangement violates the 30-inch proximity requirement stipulated in NEC 555.17b. So, what constitutes an appropriate disconnecting means for show receptacles? Acceptable alternatives include the following. Firstly, circuit breakers. Circuit breakers are suitable if mounted within 30 inches of the receptacle. Secondly, switches. Switches must be clearly labeled, dedicated to the specific receptacle, and positioned within 30 inches of it. Thirdly, plug-in disconnects. Plug-in disconnects, specifically designed for use as disconnecting means for show receptacles, must be mounted within 30 inches of the receptacle. It's crucial to remember that the disconnecting means must have the capacity to open all ungrounded conductors. Furthermore, it must be appropriately rated for the voltage and current demands of the circuit it protects. To delve deeper into the specifics of circuit breaker selection, one might consult NEC Table 310.15b16 for ampacity ratings based on conductor size and insulation type. For example, a 12 American wire gauge copper conductor with THHN insulation operating in an ambient temperature of 30 degrees Celsius typically has an ampacity of 30 amps. However, dirting factors may apply based on the number of current carrying conductors in a raceway or cable, as detailed in NEC Section 310.15c. When selecting a switch, it's essential to ensure that it's horsepower rated if it's intended to control motor load. For example, a 5 horsepower, 230 volts motor will require a switch with an appropriate horsepower rating to safely interrupt the motor's current. Additionally, the switch must have a voltage rating equal to or greater than the system voltage. For shore power applications, ground fault protection is also a critical consideration. NEC Section 555.19 mandates ground fault circuit interrupter protection for personnel for receptacles rated 30 amps or less. This protection is designed to detect small ground faults and quickly interrupt the circuit, minimizing the risk of electrical shock. Ground fault protection can be provided by a ground fault circuit interrupter circuit breaker or a ground fault circuit interrupter receptacle. The ground fault circuit interrupter trips when it detects an imbalance between the current flowing to and from the load. This imbalance indicates that current is leaking to ground, which could be through a person. The trip threshold for a ground fault circuit interrupter is typically 5 mA. In addition to ground fault protection, surge protection is also recommended for shore power applications. Surges can be caused by lightning strikes or other electrical disturbances and can damage sensitive electronic equipment. Surge protective devices are designed to divert surge current away from the equipment they protect. They are rated in terms of their surge current capacity, typically measured in kiloamps. A surge protective device should be selected with a surge current capacity that is appropriate for the expected surge environment. Proper wiring methods are also essential for shore power installations. All wiring must be installed in accordance with the NEC and must be protected from physical damage. Conductors must be sized appropriately for the load they will carry, and connections must be made using approved methods. In corrosive environments, such as marinas, special precautions must be taken to protect the wiring from corrosion. This may include using corrosion-resistant materials or applying a protective coating to the wiring. Regular inspections and maintenance are also important for ensuring the safety and reliability of shore power installations. Inspections should be performed by a qualified electrician and should include a visual inspection of the wiring, connections, and equipment. Any damaged or worn component should be replaced promptly. Maintenance should include cleaning the equipment and tightening any loose connections. By following these guidelines, you can ensure that your shore power installation is safe and compliant with the NEC. Remember to always consult with a qualified electrician for any electrical work. When considering the placement of the disconnecting means, accessibility is paramount. The disconnecting means should be located in a readily accessible location free from obstructions. It should be easily visible and clearly labeled so that it can be quickly identified in an emergency. The disconnecting means should also be located in a dry location to prevent corrosion and electrical hazards. In addition to the location requirements, the disconnecting means must also be properly rated for the application. The disconnecting means must be rated for the voltage and current of the circuit it controls. It must also be rated for the interrupting capacity required to safely interrupt the circuit under fault conditions. The interrupting capacity is the maximum current that the disconnecting means can safely interrupt. It is important to select a disconnecting means with an interrupting capacity that is greater than the available fault current at the point of installation. The available fault current is the maximum current that would flow in a circuit under a fault condition. It can be calculated using a fault current calculator or by consulting with a qualified electrician. When selecting a disconnecting means, it is also important to consider the environmental conditions. In corrosive environments such as marinas, it is important to select a disconnecting means that is made of corrosion-resistant materials. In wet locations, it is important to select a disconnecting means that is rated for wet locations. Wet location rated disconnecting means are designed to prevent water from entering the enclosure and causing electrical hazards. In addition to the NEC requirements, there may also be local codes and regulations that apply to shore power installations. It is important to check with your local authority having jurisdiction to determine the specific requirements for your area. By following the NEC and local codes and regulations, you can ensure that your shore power installation is safe and compliant. Remember to always consult with a qualified electrician for any electrical work. Here's a breakdown of key NEC sections related to shore power. Firstly, NEC 555.1 Scope. This article covers the installation of wiring and equipment in areas used for docking, mooring, or storing boats, including marinas, boatyards, yacht clubs, and similar facilities. Secondly, NEC 555.3 Grounding. All metal parts of electrical equipment and wiring systems must be grounded to provide a low impedance path for fault current and minimize the risk of electrical shock. Thirdly, NEC 555.4 General Requirements. Wiring methods must be suitable for wet locations and corrosive environments. All equipment must be listed and labeled for its intended use. Fourthly, NEC 555.5 Wiring Methods. Wiring methods must comply with Article 300 and be suitable for the environment. Underground wiring must be installed in rigid metal conduit, intermediate metal conduit, rigid polyvinyl chloride conduit, or reinforced thermal-sitting resin conduit. Fifthly, NEC 555.7 Receptacles. Receptacles must be of the grounding type and must be protected by ground fault circuit interrupters for personnel. Receptacles must be located at least 12 inches above the deck surface. Sixthly, NEC 555.10 Overcurrent Protection. Overcurrent protection must be provided for all circuits and equipment. The overcurrent protection device must be rated in accordance with the ampacity of the conductors it protects. Seventhly, NEC 555.11 Wiring on piers and floating docks. Wiring on piers and floating docks must be installed in a manner that prevents strain on the conductors and connections. Wiring must be supported by insulators or other approved means. Eighthly, NEC 555.12 Wiring below low water. Wiring below low water must be installed in a watertight enclosure or cable. The enclosure or cable must be located at least 18 inches below the low water line. Ninthly, NEC 555.13 equipment enclosures. Equipment enclosures must be weatherproof and corrosion resistant. Enclosures must be properly grounded. Tenthly, NEC 555.15 electrical datum plane. Establishes a reference point for measuring heights and clearances of electrical equipment in marine locations. 11thly, NEC 555.17 disconnecting means. Each shore power receptacle must have a disconnecting means located within 30 inches of the receptacle. The disconnecting means must be readily accessible. 12th, NEC 555.19 ground fault protection for personnel. Ground fault protection for personnel is required for all receptacles rated 30 amps or less. 13th, NEC 555.20 feeders and services. Feeders and services must be sized in accordance with Article 220 and must be protected by overcurrent protection devices. 14th, NEC 555.21 electrical equipment. The electrical equipment must be suitable for wet locations and corrosive environments. Equipment must be listed and labeled for its intended use. 15th, NEC 555.22 hazardous classified locations. Specifies requirements for electrical equipment installed at hazardous locations such as fuel storage areas. 16th, NEC 555.23 gasoline dispensing areas. Specifies requirements for electrical equipment installed in gasoline dispensing areas. 17th, NEC 555.24 boat hoists. Specifies requirements for electrical equipment installed on boat hoists. These NEC sections provide a comprehensive set of requirements for electrical installations in marinas and boatyards. By following these requirements, you can ensure that your electrical system is safe and compliant. Regarding the 30-inch rule for disconnecting means, it's important to clarify its purpose. The primary objective is to provide a readily accessible means of disconnecting power to the receptacle in case of an emergency. This allows for quick and safe isolation of the circuit, preventing potential hazards such as electrical shock or fire. The 30-inch distance is intended to ensure that the disconnecting means is within easy reach of someone using the receptacle. This is especially important in situations where someone may be in contact with water or wet surfaces, as electrical shock can be more severe under these conditions. The disconnecting means should be clearly labeled to indicate which receptacle it controls. This will help to avoid confusion and ensure that the correct circuit is disconnected in an emergency. The label should be durable and weather resistant to withstand the harsh marine environment. The disconnecting means should also be protected from physical damage. It should be located in a position where it is not likely to be struck by boats or other equipment. If the disconnecting means is located in an exposed area, it should be protected by a guard or barrier. In addition to the 30-inch rule, the NEC also requires that the disconnecting means be readily accessible. This means that it should be easily accessible without the need for tools or other equipment. The disconnecting means should not be located behind locked doors or other obstructions. The disconnecting means should also be located in a well-lit area so that it can be easily seen. The NEC also requires that the disconnecting means be rated for the voltage and current of the circuit it controls. The disconnecting means should be able to safely interrupt the circuit under fault conditions. The interrupting rating of the disconnecting means should be greater than the available fault current at the receptacle. The available fault current is the maximum current that would flow in the circuit under a fault condition. It can be calculated by a qualified electrician. The NEC also requires that the disconnecting means be of the proper type for the application. For example, a circuit breaker is typically used as a disconnecting means for a receptacle. However, a switch may also be used if it is properly rated for the application. The disconnecting means must be listed and labeled by a recognized testing laboratory, such as underwriters' laboratories, to ensure that it meets safety standards. In addition to the NEC requirements, there may also be local codes and regulations that apply to shore power installations. It is important to check with your local authority having jurisdiction to determine the specific requirements for your area. Some local codes may require additional safety features such as surge protection or ground fault monitoring. By following the NEC and local codes and regulations, you can ensure that your shore power installation is safe and compliant. Remember to always consult with a qualified electrician for any electrical work. Regarding shunt trap breakers, while they offer remote operation capabilities, their application in this specific scenario is problematic due to the code's emphasis on immediate, local disconnection. Shunt trap breakers are often used in situations where remote shutdown of a circuit is desired, such as in industrial facilities or large commercial buildings. However, in the context of shore power receptacles, the NEC prioritizes the ability of someone near the receptacle to quickly disconnect power in an emergency. A shunt trap breaker typically requires a separate control circuit and a push button or other control device to activate the trip. This adds complexity and can delay the disconnection process compared to a simple circuit breaker or switch located right next to the receptacle. Furthermore, the reliability of the shunt trap mechanism is a factor to consider. If the control circuit fails or the shunt trap mechanism malfunctions, the breaker may not trip when needed, potentially creating a hazardous situation. In contrast, a manually operated circuit breaker or switch provides a direct and reliable means of disconnecting power. It is also easier to inspect and maintain. The NEC focus on local disconnection is also driven by the potential for confusion and communication issues in emergency situations. If a remote operator is responsible for tripping the breaker, there could be delays or misunderstandings that could jeopardize safety. By requiring the disconnecting means to be located right next to the receptacle, the NEC ensures that the person who needs to disconnect power can do so quickly and easily without relying on someone else. In summary, while shunt trap breakers have their place in electrical systems, they are not suitable as the primary disconnecting means for shore power receptacles due to the NEC requirements for readily accessible and locally located disconnection. The code prioritizes immediate safety and ease of operation in emergency situations.